So the 3D printing workstation in our lab currently faces several problems due to the inefficient process mapping, ergonomics risk, and a lack of automation. To address these problems, we develop a solution focusing on the upgrade of the station on the upgrade of the workstation 2.0 and 3.0 by integrating the industry 4.0 and the human factor 4.0. So the initial diagnostics that we made was through the process of mapping flowcharts and stream mapping to analyze the current state of operation, which allowed us to identify the key areas of improvement. By applying the basic quality and productivity tools, we identified the possibility to reduce the cycle times by about 20 to 10 to 20% and the downtime by 20%. Well, then, keeping this in mind, we designed our project in order to focus on transforming a 3D printing workstation by integrating the 4.0 technologies to improve efficiency, ergonomics, and to improve efficiency and ergonomics. The current workstations had some areas of opportunity regarding the manual replacement of the filaments, inefficient workflow, poor ergonomic design, which leads to delays and poor efficiency as as well as a lag in automation compared to the industry standards. Well, then, in order to address these challenges, we propose the incorporation of a several cyber physical components, which are the addition of IoT sensor cobots into the 2.0 and 3.0 workstations. The implementation of the IoT will reduce downtime by having predictive maintenance, and the cobot will automate the replacement filament, which will be reduced the manual labor by 50% and will increase production efficiency. Meanwhile, the digital twins allow us to simulate workflows and changes without disturbing the actual operations. And on the other hand, the ergonomic science plays a major role by prioritizing the operator's well-being. Well, the analysis of the MTM1 and the MTM2 reduced by 20% unnecessary movements, and by using the NIOSH lifting equation, we confirmed that the implementation of the cobots will reduce the risk of injuries due to the constant and repetitive movements that were involving the workstation. Also regarding the norms, our workplace were successfully complies with NOM 036 and NOM 4 and NOM 30, which will ensure a safer workplace for the operations. And regarding the financial aspect, our project is viable due to cost, the payback periods, and the results of productivity will and the implementation of the IoT sensors will cost around about 5 grand and about 15 grand with a payback period of about 1.5 months. And the cobot costs around 15 grand, 15 to 45 grand, depends on the model. And implementation will reduce the labor risk by about 50%, and will have a return of investment in about 3.5 months, which the implementation will result in about a 20% increase in productivity, which would mean better or optimizing, well, better flow of the workstation. And also, we took into account the lean manufacturing practices and the implementation of the 5S methodology, an AI-driven schedule for workflow optimization, and a real-time monitoring system to align a demand. Also, through the automation and ergonomic adjustments, the safety of the operator is enhanced and the energy consumption is reduced, uh, which will align with some sustainability measures. Well, in conclusion, our 3.0 workstation integrates automation, digitalization, and a human-centered design, ensuring a safe and efficient workspace. and also by li- delivering industry 4.0 and human factor 4.0. We enhance productivity while prioritizing the well-being of the worker and a better sustainability. Thank you.